In this online lecture, we're going to talk about why cyclic alkanes pucker. And what does that mean? Well, here's our key point. We're going to see cyclic alkanes pucker to help alleviate eclipsing and angle strain. Now, what does this all mean? Let me show you an example. Imagine we have a 4-carbon cyclic alkane like cyclobutane. And let's pretend for a second that this is the actual 3-dimensional structure of it. That means that if we were to look from this perspective right here, then this is what we would see basically. We would notice that this hydrogen right here is eclipsing with the hydrogen behind it here. And we learned in a previous online lecture that eclipsing interactions are higher energy, less stable. So what we're learning here is that cyclic alkanes pucker or bend like this in order to relieve the eclipsing that we see here. Now let me make sure you see this. Let's number the carbons for the structure on the left. Again, we have the 4 carbons within the ring. What you see here on the right, these would be those 4 carbons right here. And what I want to show you here is that cyclobutane is not really just a flat ring. The structure on the right shows it being bent or puckered. And let's do this. Let's fill in those hydrogens. This is more closer to the reality. This is what they would look like. So this structure on the right is closer to the actual picture of what cyclobutane would look like. Now, there's another reason why these rings pucker. Let's again go back to a simplified version of cyclobutane, such as what you see here. If we were to investigate each carbon in the ring, we would see that it is sp3 hybridized, which means that it should have 3 sp3 hybridized orbitals about it. And let's just focus on the orbitals that would be involved in the ring. Here they are. Notice if this was the reality, then the angle between these orbitals in this picture right here would have to be 90 degrees. But remember, we learned in the previous online lecture about sp3 hybridization is that the angle between the orbitals would rather be 109.5 degrees. Which means if cyclobutane were to exist as a perfect square, it would force the orbitals in an angle that's unstable. So some of the terms that we would apply here, we would say that cyclobutane, because of this, has a lot of angle strain. And the bonds that make up the ring could be termed banana bonds. Notice that top bond in the ring is bent and has a banana shape to it. This causes less overlap of the orbitals in this molecule, and this leads to less stability. But again, if the ring puckers, then it enables the bond angles to be closer to 109.5 and relieves some but not all of the angle strain. So this becomes another reason why cycloalkanes pucker. So what's our key point here? All we're trying to get across is that cycloalkanes pucker to help alleviate both eclipsing and angle strain.